Hi friends, in this video I am going to discuss about another population interaction, that is competition. In competition, both the species A and species B are affected by uh, the competition. So neither of them are benefited. So both of them are harmed, that is species A and species B. So when Darwin he spoke of the struggle for existence and survival of the fittest in nature, he was convinced that interspecific competition is a potent force in organic evolution. Totally unrelated species could also compete for the same resource, that is the recent studies. So whereas interspecific competition is also a potent force that Darwin had also come to a conclusion with. So there is examples for it like flamingos versus resident fishes. Flamingos and resident fishes represent examples for interspecific. Two different species they are. In the shallow South American lakes, the visiting flamingos and resident fishes compete for their common food. That is the zooplankton in the lake resources. Both of them require zooplankton as a source of food, and zooplankton need not be limiting for competition to occur, but when it becomes limiting, a competition occurs. So this is the resident fishes and flamingos. They compete for the zooplankton. And there is another variety of competition that you can notice is interference competition. So you might notice in certain examples the feeding efficiency of one species might be reduced due to the interfering and inhibitory presence of the other species. Even if resources are abundant, that is food and space are abundant, this happens. The example for this is Gauss and other experimental ecologists, they came to a conclusion of Gauss exclusive principle. When resources are limited, the competitively superior species will eventually eliminate the competitively inferior species. But evidence for such competitive exclusion occurring in nature is not always conclusive. Strong and persuasive circumstantial evidence does exist, however, in some cases. So you can take up the Gauss exclusive principle in case of Abingdon tortoise, which was found in Galapagos Island versus goat. So Abingdon tortoise in Galapagos Islands, they became extinct within a decade after goats were introduced on the island. This was apparently due to the greater browsing efficiency of the goats when compared to Abingdon tortoise. So this is an example of competitively superior species replacing competitively inferior species, and an example for Gauss competitive exclusion principle. So this is the Abingdon tortoise which had lost its competition with a goat that was introduced in the Galapagos Island. The Gauss competitive exclusion principle, it states that two closely related species competing for the same resources cannot coexist indefinitely, and the competitively inferior one will be eliminated eventually. That is what is the statement. Now, competitive release. A species whose distribution is restricted to a small geographical area because of the presence of a competitively superior species is found to expand its distributional range dramatically when the competing species is experimentally removed. The example for this is Cornell's elegant field experiments, barnacles they are, on the rocky seacoast of Scotland. The larger and competitively superior barnacle, Balanus, it dominates the intertidal area and it prevents the smaller barnacle, Catamelus, from that zone. When you remove this barnacle, Balanus, Catamelus is going to grow there. So the balanoidis, Catamelus stellitis, you can see the smaller barnacle and the larger barnacle. So the upper intertidal zone, it is having Balanus, and it prevents the Catamelus to survive. This is the upper intertidal zone. Middle intertidal zone, where it can survive, Balanus outcompetes Catamelus for space. So the Balanus is generally found in the lower tidal zone. So the lowest tides, that is how where you find the when you remove this Balanus, Catamelus is going to be found in all these zones. So that is competitive exclude Cornell's elegant field experiment, so that you can remember about. Then resource partitioning, always competition need not be lethal, so they can also go for resource partitioning. So the species facing competition, they evolve mechanisms that promote coexistence rather than exclusion. One such mechanism is resource partitioning. If two species compete for the same resource, they could avoid competition by choosing, for instance, different times for feeding or different foraging patterns. So MacArthur showed that five closely related species of warblers, that is birds, living on the same tree, they were able to avoid competition and coexist and co-live due to this behavioral differences in their foraging activities, that is going for the food. So the Cape Mary warbler, they usually went to the canopy of the tree, tip of the canopy of the tree. The black Vermilion warbler, they depended on this next zone. So the third variety, black-throated green warbler, they depended upon the food of below that of the black Burman warbler. Then bay-breasted, they went for the next zone. So this is how you can see nearly five varieties of warblers having different foraging area on the same tree, and thus they are avoiding competition with each other and they are coexisting. So this is partitioning of the resources and thus survival of all of them and coexisting without competition harming them. So these are the photographs of the warbler birds that are found partitioning the resources on a tree and feeding on different zonal areas of the canopy of the tree. Thank you.